When you click a link, you engage a network of trillions of individual data paths. This infrastructure connects nearly every piece of recorded human history into a single global index. The World Wide Web became the dominant system because it was incredibly simple to build. But the basic building block of that system, the standard hyperlink, has a structural limitation. It operates as a one-way street. When a web page links to another document, the receiving page has no record of the connection. The link points blindly outward, ignoring the context of its destination. Tim Berners-Lee designed this architecture in the early 1990s. The one-way link was a practical compromise to get the web off the ground quickly, not his ideal vision for how computers should connect ideas. We rely on this tool billions of times a day, yet the mechanism itself remains blind to the actual meaning of the text it connects. The original vision for digital connection dates back to 1945. Vannevar Bush imagined a machine called the Memex, designed to build organic associative trails that mimicked the way the human brain naturally links one concept to another. In the 1960s, Ted Nelson took this further with Project Xanadu. He demanded strict, two-way connections that linked an exact sentence in one document directly to an exact sentence in another. These projects stalled because of a massive logistical bottleneck. Manually drawing precise subset-to-subset connections between thousands of documents required an impossible amount of human labor. The Internet adopted the blunt, one-way hyperlink because human cognition could not scale fast enough to map the web the way Bush and Nelson intended. In 2017, researchers published the "Attention is All You Need" paper. While it is famous for generating text, the transformer architecture's underlying mechanism is a specialized engine for calculating how any two pieces of information relate to one another. The attention mechanism breaks raw text into data points called tokens, calculating the semantic weight between them. Fed two separate documents, like Blake's poems The Lamb and The Tiger, it evaluates them together, locating semantic relationships and bridging specific lines of text. This cross-attention process automatically identifies exact conceptual links, performing the precise task that Vannevar Bush dreamed humans would one day do by hand. The architecture of modern AI provides the logic needed to bypass the 60-year-old manual labor bottleneck. It automates the extraction of complex relationships at scale. This brings us to Hilink. It is an open-source project featuring a command line engine and a web interface that bridges transformer mathematics directly into the human web experience. The Node.js engine feeds two target documents simultaneously into a large language model's context window, like the Gemini API. A structured prompt forces the AI to iteratively scan the texts, extracting the single most valuable connection remaining between them, mapping relationships point by point. The engine continues extracting links until it hits one of three strict termination conditions. The model signals exhaustion, the quality score drops below threshold, or hits a hard-coded safety cap. Hilink repurposes the large language model. Instead of generating new paragraphs of text, it acts as an automated high-scale hypertext linker. Users interact with this output through a Chrome extension called Lighter. As you browse, the extension dynamically overlays these generated two-way connections directly onto the text of existing web pages. Hilink classifies relationships into three categories. First is a nest, where one text selection semantically encompasses the other entirely. Next is touch, where selections share semantic proximity, pushing or pulling each other. Finally, echo, where texts relate in structural form more than direct meaning. By categorizing and counting these specific intersections, the total number of hylinks produced between two documents now serves as a measurable metric of how closely they are related. These links carry specific labels and weightings. By making the connection bidirectional and classified, the software turns a simple pointer into a descriptive, multidimensional relationship. The software changes the basic structure of the web. We are moving toward a model where every document is aware of its neighbors, weaving static pages into an interconnected map of concepts. The entire Hilink repository is released into the public domain under CC 0.1.0 Universal. The project operates on a specific legal ethos: knowledge lives in relationship, not ownership. You can test this system right now by using the web app, or you can explore the open-source GitHub repository to help build and refine this architecture yourself. It took this specific shift in machine learning to finally execute the design that early computing pioneers could only describe.